for this last session, Ties de Kock, talk about routing information service.
Let's try the blue one. We are using the blue microphone. We are using the blue microphone, and I can hear myself, so I think it works. I am pleased to provide SCC, and I'll talk about the RIS, routing information system. And I'll skip the short overview now and dive into the content more directly. RIS is a route collector project. We keep current and historical BGP state and make it publicly available for reuse. To do so, we have a worldwide group of route collectors, and these route collectors are mostly at internet exchanges and, for example, at MSKIX in Moscow, which is present here at the event, I think. And with these route collectors, we pair with BGP with other networks. And when the collector is at an ISP, we connect over the ISP VLAN if possible. We have also have some collectors that are in Amsterdam, which we use to create a multi-hop BGP session. So we can collect data not only from the locations where we have a collector, but locations worldwide. And by now we have 25 years of BGP history, which really is a long time. As you can see, these route collectors are spread around the world, and not as kind of centered in Europe, to be honest, but using multi-hop collection, which really is the future for us infrastructure-wise. We can collect data from everywhere. And we have 1,300 plus active sessions with our peers. Our route collectors run XBGP, which is a BGP speaker, and it's not really a router. Because we want to capture what's happening in BGP and not do forwarding, we do not need to build a routing table there and change how forwarding is done, etc., etc., etc. So this allowed us to design it in a different way. In this diagram, you see how the route collector, how the whole platform is structured, where we have extra BGP, there's a peering session with BGP peers, there's a local queue to cache the data, and the data is collected in the right SCC network in our message queue Kafka. And from this message queue, we get the data and we process it. So, for example, we get the BGP updates, we stream it into a live looking glass, and we also make the information available through RIS Live, so all networks can use as close to real-time information as possible. So I've tried to introduce what RIS is, and now I'll explain some of the use cases that there are. We know that network operators can really easily see the state of BGP in their network right now, but when an incident happens and you want to look back, that's actually quite hard. And there are many groups that actually need this at times. So the first group is easy, it's network operators. We this data, we build tools at the right SCC, others build tools that allows you to look at historical BGP data. For example, I see this prefix, and what other ASNs have announced this prefix before. And talking about tools, the data that we collect is publicly available, and developers can use this data to build their own tools. One example there is BGP Alerter that I mentioned here, where it takes the data from RIS Live, reads it, and then can send you an email, a Slack message, etc. when either one of your prefixes is announced by a different network or something changes in the RPI state. Another group that uses this data to make the internet better are researchers that investigate things that happened on the internet. And one thing I want to mention here is an incident in 2023 when routes with an invalid transitive BGP attribute 28 were announced, and some routers rejected these BGP updates. Then, depending on the defaults that you set, and for one of the vendors, the default was to reset the session when you see such a route. The session between a lot of routers would reset and is propagated throughout the internet, causing a decent disruption. And finally, you've seen a lot of presentations yesterday and today about the internet. When you want to say something about the structure of the internet, you need data. Yeah, this is a data set for that. We are a platform that collects this data and keeps it long term, which means that the total amount of data that we need to store only grows over time. And we made a software change in 2023 that dropped the amount we need to store. This volume only increases, and we're storing about 650 gigabytes of BGP update data every month. And we want to see as much of the internet as possible, but we also want to be careful with which layers we add, because we want to capture the most relevant information. And that we are capturing the most relevant information about what's happening in the internet instead of shifting data also means that we have a quite interesting peering policy where we want to add peers that add unique information. And we want to collect information that's separate from what we already see. Because everything that all the traffic that goes through transit is very easy to see from far away. But traffic that's through an ISP or local routes or anything not exposed means that we also need to capture it relatively locally. That means we have kind of a mixed message about peering with this, because we really want to pair with the networks and add new information for us. At the same time, we're really careful about choosing what networks we add, because the volume increases and we want to keep it long term. We want to provide accurate and reliable routing information, but we also want this project to be sustainable and to be able to keep this history so you can look back. We will have a list of the ASNs that we are interested to pair with, available in the slides that are available online. Since we have a tool that analyzes which networks are far away between air quotes from RIS, and they didn't make it into the version that I see now, but these will, yeah, you can check it out. And if you're on that list, please get in touch with us, because it will really increase the visibility we have with RIS into the visibility, into what's happening with BGP routes in Central Asia. Because we do not have a BGP collector here, and honestly, we really need at least one pair in Kyrgyzstan after this event, I hope. The end result of collecting this data is that tools use this data, such as our own tool, RISE-Stat, BGP Alerter that I also mentioned, and a website by the Internet Initiative Japan, where you can do reporting about BGP. And yeah, that's a really nice one, that last one, aggregates a lot of data sources. And there's also a lot of research done with by RIS. Some posts on RISE Labs, for example, the post about Palestine internet connectivity seen in BGP by Cassini, and research by colleague Emil Abel about the resiliency of the internet in Ukraine and how the routing topology changed during the war, which is also available on RISE Labs. And you've also implicitly seen this data in the reports that we show as the RISE NCC. As I said, there's a lot of research on using this. A fraction of it is visible on RISE Labs. If you scan the QR code, that will filter the articles that include this. If you prefer to read academic papers, there's also a lot of academic research using this data. It goes quite deep, but there are very interesting things to learn, or realizations when you realize that the academic perspective on networks is different from what operators think. This is my short presentation on this. Try to compress it a little bit. Thanks for your attention.